Hi guys. Today we're going to take a look at day 2 of solving trig equations. So if you look at your notes, it's just one page of notes. Again, at the top, I went ahead and filled in my chart, so it'd be all good to go. These quadrants, you don't have to do it this way. I just think this is helpful to be able to, literally see each of the angles that could be possible solutions to these. But you could just put the reference angles and find the other ones on your own. The only difference really today we're just going to solve some more equations. I'm going to show you some things that can come up. The biggest difference though is just going to be how we write our answers. Yesterday we were focusing on the fact that there are an infinite number of solutions to all of these equations. Okay? Because these graphs go on forever and ever and ever, the solutions would go on forever and ever and ever as well. So today we're going to say, okay, we understand that. We know these go on forever. But today we're only going to look for solutions that are between 0 and 2 pi. So in other words, within one revolution. So we want all the angles that are within one, complete revolution, and we're not going to then find another angle that's exactly the same as one of our answers but is like an extra loop around. So we're not going to worry about those, but we do need all solutions that are within one revolution. So for example, let me do number 1. So this is going to solve just like the ones we did yesterday. So move the radical 3 over, so 2 sine theta equals negative radical 3, divide by 2. You could probably have done those 2 steps at the same time. I'd be okay with that. So theta equals the inverse sine of negative radical 3 over 2. So we'll go to our chart. Sine radical 3 over 2, this is negative. So again, think about that. We want the answers that are in quadrants 3 and 4. So radical 3 over 2, we're going to do 4 pi over 3 and 5 pi over 3. So those are going to be our solutions. So theta equals 4 pi over 3 plus 2 pi k, or theta could equal 5 pi over 3 plus 2 pi k. Now, for this problem, though, we only want answers that are within one revolution. So if I add 2 pi to this angle that I already have, I'm going to get an answer that's bigger than 2 pi, right? Obviously, adding 2 pi to anything is going to give me a number that's bigger than what I want. So for this one, I'm actually done. 4 pi over 3 is one of my solutions. 5 pi over 3 is another one, and that is all we're looking for today. Okay? Now, it's not always going to only be these 2. There are some situations that can come up where we are going to get 4 answers, we could get 3 answers, and that's some of the things I'm going to show you today. Okay? So let's look at the second example. So I'm going to move the sign over. So 2 theta equals the inverse sine of positive 1/2. I'm saying that for a reason. So sine is positive in quadrants 1 and 2. Again, I'm going to look up at my chart. I'm going to see sine 1/2, and it's going to be pi over 6 and 5 pi over 6. So 2 theta equals pi over 6 plus 2 pi k, or 2 theta, we haven't solved for theta yet, we still have 2 theta. 2 theta equals 5 pi over 6 plus 2 pi k. All right, so why did I add the 2 pi k? We just found out on the last problem that that's pointless. Adding the 2 pi is always going to give me an answer that's bigger than 2 pi, so we don't need it. However, on this problem, our next step is to divide by 2. Okay, we haven't solved for theta. And remember, everything gets divided by 2. So this will be theta. This will now be pi over 12 plus, and this will now be 1 pi k. So this is going to get us another answer right here. We're going to have pi over 12. Think of that as 1/12. Think of pi as 12/12. And when I add pi to that answer, I'm going to get 13/12, which is another solution that's within 1 revolution. So not only do I have pi over 12, but I'm also going to have 13 pi over 12. Now, if I add another 12/12 to that, I'm going to get 25/12, and that would be too big. 24 over 12 would be equal to 2. So if I'm getting an answer that's bigger than 24 over 12, then that's too much. So I can stop right there. Now I also have this part of the equation. So this will be 5 pi over 12. And again, plus 1 pi k. So 5 pi over 12 will be another solution. And again, adding 12/12 to 5/12 will give me 17/12, which is less than 2. But if I add another 12/12, I'll go over. So this one has 4 solutions. So we always need to throw in that extra, plus 2 pi k to see whether or not it's going to generate some extra solutions. Okay? All right. Let's look at 3. So this one's a little bit different. This one has a subtraction in it. Again, order of operations, I have to get rid of the tangent first. So this is going to stay put for now. So theta minus pi over 2 equals the inverse tangent of 1, positive 1. So this would be quadrants 1 and 3. So tangent 1, and you're going to look up at your chart. I'm not going to pull this down every time, but pi over 4 and 5 pi over 4. Those are our solutions. So this part that we have solved for so far, theta minus pi over 2, is going to be equal to pi over 4 plus, remember, tangent has a period of 1 pi, so I'm just going to add pi k, or that theta minus pi over 2 could be equal to 5 pi over 4 plus pi k. And then I have to solve for theta. So I'm going to add 1/2 pi to both sides. Now, when you do that, a couple things. First off, I'm going to need a common denominator to add these. So I'm going to have pi over 4. I've got my plus pi k. And then I'm going to add, I'm going to think of this as 2/4. So that's what I'm adding to the other side, 2 pi over 4. Now, this may look a little weird. When you add these, you don't distribute. Okay? So on the other problems where we had to, like this one where we had to divide by 2, we divided everything by 2. But this one, you're only going to combine like terms. So this 1/4 and that 2/4 are going to get added together, and you're going to get 3 pi over 4. And you're still going to have this plus pi k. That isn't going to get affected by adding those two. Over here, I've got 5 pi over 4 plus pi k plus, and then this is going to come over here. Again, I'm going to write that as 2/4. And when I combine like terms, 5/4 and 2/4 is going to give me 7/4 plus pi k. So let's see what kind of answers we have. We have 3/4. That's within 1 revolution. If we add pi, so think of that as 4/4 to 3/4, we're going to get this answer actually, 7/4. And 7/4 is less than 2. 8/4 would be 2. So if we add another pi to that to see if there's a third solution, it's not going to work. It's going to be bigger than the answers we want. So this one only has 2 solutions. All right, let's take a look at example 4. So this one's a little bit different. It's got a tangent squared. So let's see how that's going to change things. So first off, it's going to start off normal. We're going to move the 1 to the other side. Tell you what, I'm going to move the 1 over, and I'm going to divide by 3. So hopefully that doesn't bother anyone. So 1/3. Now, at this point, you can't move the tangent over yet. You don't have a tangent. You have a tangent squared. So we're going to have to take the square root of both sides to get rid of that. So if I take the square root of this side, I'll just have the tangent of x. On this side, I'm taking the square root of this whole thing. Now remember, when we take the square root, when you're solving an equation like in algebra, we want all solutions. That's what we're going for here. So it's going to be both positive and negative square root of 1/3, which is actually the square root of 1 over the square root of 3. And if we rationalize that, we are going to get plus or minus radical 3 over 3. So again, it's 1 over radical 3, and when we move the radical up, this is what we get. So for our next step, now we can do the inverse tangent. And notice that we got a number that we're familiar with. That's a number that's on our chart. But we want both positive and negative radical 3 over 3. So when we go to the chart and we look at radical 3 over 3, we want all these angles. We want every solution that could possibly work for the tangent of that angle being radical 3 over 3, both positive and negative. So x equals, and it's going to be pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and that is right at almost 2 pi. So adding any multipliers or any multiples of pi to any of those solutions is just going to either give you one of these angles, or it's going to give you an angle that's too big. So that would be our solution. Okay? Now, number 5. Try number 5 on your own, and then after you've tried it, take a look at my solutions. So right now, hit pause, and then hit play when you get done. All right, so here's my solution. So I moved the tangent over, negative radical 3, tangent is negative in quadrants 2 and 4. So 2 pi over 3 and 5 pi over 3, those are my angles. I added pi k, but then I had to divide everything by 2, which turned the pi's into pi over 2k. It turned the 2 pi over 3 into 2 pi over 6, 5 pi over 3 into 5 pi over 6. And so those are 2 of my answers. 2 pi over 6, which is actually pi over 3 if you reduce it, and then 5 pi over 6. But then we also have to check and see if adding that little extra addition is going to generate any other solutions that are between 0 and 2 pi. So pi over 3, there's 5 pi over 6, that one. If I add, think of pi over k as 3/6. So I added 3/6 to 5/6 and got 8/6, which is still less than 2. That actually equals 4 pi over 3. And then I added 3/6 again and got 11/6, and that's still less than 2. So those are 4 solutions to this problem. All right, last one, I want to show you how you could solve one of these using a calculator, which the first thing you'd have to do is get your calculator into radian mode. So I have a little button here that says DRG, and I can click over to radians, and now I'm all set. So to solve this equation, it's just going to be the inverse sine of 0.7. So inverse sine 0.7, and my calculator tells me the answer is 0.775, let's say 4 radians. Okay? Now, that is an angle that's in quadrant 1 that has a measure of 0.775 radians. Now, there's another one over here in quadrant 2 that also has that same reference angle, but that would be 3.14 minus that. So if I took 3.14 and subtracted 0.7754, because 3.14 is pi, I would get 2.3646, which is another angle in quadrant 2 that also has that same radian measure. So this is going to be really important in the next chapter.